if we have a function of x which contains x to a power, then the derivative of the function of x it follows this formula here. So the power comes down as the multiplier or the coefficient of the x term, and the power drops by 1. Let's do an example to see how this works in practice. So if we have a function which is a parabola, which is x squared, then the derivative of that function is the 2 is our n, and that comes down as the coefficient, becomes 2x, and then the power drops by 1. So 2 minus 1 is 1. And we don't need to write the 1, so it's just 2x. So that's our derivative of the function f of x. Now there's different ways that we can write our function. You might see y equals x squared. And the derivative can be written dy dx, which means the derivative of y with respect to x. That's the same thing, it's 2x. Or you might see it written as y dash. The dash means the derivative of y, and again it's 2x. Let's do some examples to practice using this. Alright, so I'm going to work on these 4 questions here. Starting with number 1, we've got 2 separate terms. Remember, terms are divided by plus or minus signs. So we differentiate each term on its own. Now I'm just going to write up here our formula, f of x equals x to the n, and the derivative, f dash of x, is equal to nx to the n minus 1. So let's go to the first question, 4x squared. So dy dx. Now I'm going to mix up which I'm using of these, just so you get used to seeing the different ones, the different symbols for the derivative. Now 4 is our coefficient of x squared, and that remains, and we differentiate the x squared. So 2 is the power that comes down to multiply the x, and the power of x falls by 1. We keep the plus sign, and then we differentiate this term here. Now this is 3x to the power 1. We just don't need to write the 1. So the 1 will come down as the multiplier, and x will go to the power 0. Now anything to the power 0 is 1. So this last term becomes 3 times 1 times 1, which is just 3. So let's multiply out our first term. 4 times 2 is 8, just x, plus 3 times 1 times 1 is 3. So the derivative of this first expression is 8x plus 3. For question number 2 over here, one of our terms is just a number. Now if we think about a graph which is just, say, y equals 4, and I'm to plot that, that is simply going to be a straight line at y is equal to 4. And it's a horizontal straight line with a gradient of 0. Now if you recall, when we're finding the derivative, we are finding the gradient. So the gradient of just that number part is 0. So any numbers on their own, when you find the derivative, they just become 0. So the derivative of our expression here, this is our x squared that we've already done, so that becomes 2x plus 0, so the derivative is just 2x. For question 3, we've got x as the denominator of a fraction. We can't differentiate it like this. What we're going to do is we're going to bring it up into the numerator, but we're going to give it a negative indice. So I'm going to rewrite it as y equals x to the minus 1. Now we can just apply our normal rules. So I'm going to use y dash for the derivative this time. And our n, in this case, our n becomes the coefficient. x to the, and the power of x has to drop. It's n minus 1, so it's minus 1 minus 1, which is minus 2. And I can rewrite that without the negative indice by just putting x back on the denominator. So it becomes minus 1 over x squared. And that is the derivative of y equals 1 over x. For our last question here, again, we've got x as the denominator, which we need to bring up onto the numerator. Now, I know a number of people would rewrite this as 2 times 3x in a bracket to the minus 4. Now, that is incorrect because the 4 is only acting on the x, not the 3 as well. Do not rewrite it like this. Try and think of it as the 2 over 3 is a coefficient, it's a constant, and it stays there. So it's 2 over 3 multiplying 1 over x to the 4. Now you can rewrite this as 2 over 3 x to the minus 4. And then we can proceed as before. The minus 4 comes down as a coefficient to find the derivative. So dy dx is equal to 2 over 3 stays. We've got minus 4 x to the, and the power drops by 1. So minus 4 minus 1 becomes minus 5. And I can multiply out the 2 and the minus 4 to give us minus 8 over 3 x to the minus 5. And the final thing is to remove the negative indice and put the x back down as the denominator. So we've got minus 8 over 3x to the power 5. And that is the derivative of our function up here.